Hey, Sander, how you doing?
Hey Edwin, how are you? I'm doing great.
Yeah, I'm fine. Just enjoying my new Lego set up here, the new Nintendo set
I am
I've
very
just built.
jealous. Yeah,
Yeah, it's really cool. It's a really cool build. So if you're searching for a next project, this is a really good one.
I've got something going
Oh,
on in the back.
the castle's under construction. Yeah.
The castle's under construction.
Well,
Yeah,
good luck with that. Talking about construction and Lego blocks and building blocks and stuff like that. You're going to talk about Orleans, right? The actor model framework.
yeah. I'm going to talk about Orleans, which is
Cool.
a special kind of actor model. I guess you are already familiar with actor models like Akka.net.
Yeah, exactly.
I think we talked about Akka.net on the show before, did we?
Yes, we had an
Yeah.
episode on that, but that was way back. But I've had some experience with Akka.net, and I'm really curious about Orleans. I've heard about it, never worked with it, so yeah,
Yeah,
let's dive in.
yeah. Well, Orleans has been around for quite a while, actually. It was first released in 2015, I believe,
Hmm.
and it was a part of Microsoft Research for a while. It has been used in quite large real world projects like Halo 4, Halo 5, the video games.
Hmm.
They are built in part on top of Orleans. Some Azure services use Orleans. So yeah, it's been out there for quite a while.
Yeah.
But lately, the Orleans team moved under the .NET team. So now they're basically part of the .NET team. So
Ah, okay.
Microsoft is talking a bit more about Orleans nowadays.
I can imagine. Yeah.
Yeah. So yeah, so let's have a look at Orleans. But before we dive into all of the technical stuff,
Hmm.
it's useful to have an example of a distributed application in mind when we talk about these things.
Hmm.
So my example is based around the Bokkentocht in Dutch. So what's a Bokkentocht? The Bokkentocht is basically a pub crawl that's organized in the village where I live. So you visit participating bars and restaurants to basically just drink a lot of bokbeer, which
Hmm.
is this seasonal type of beer. It's a type of strong lager. It originates in Germany, and this is always a great event. And I thought maybe I can improve the experience by supporting it with an app.
Cool.
So
Yeah.
this is what I have in mind. So if you open up the app, you would see two main sections. And on top, we have a map of all the participating venues. And then each venue will show the amount of participants or pub crawlers that have checked in there, right? So that way we can get a sense of how busy it is at a certain location. And then below that, the app can show a leaderboard of the highest rated beers in the event, just to help you make some tough decisions about what to order. So on the map, you can click on a venue, and that will take you to this second screen. So in the second screen, you can check in and or check out of the venue, and then you can also see the list of beers that they serve, and you can also rate them by simply giving it a thumbs up or thumbs down. So this is pretty simple bare bones app, right? But of course, once we have this app, we can now scale it out to support many pub crawl events all around the world. And for that, I'm going to need a platform that can really support that scale. And that's exactly where Orleans comes in. So Orleans is this framework for building distributed applications. And the key idea behind Orleans is to abstract away as much of the complexity of building these kind of systems, so that we as developers can simply focus on writing our application logic rather than worrying about all of the underlying infrastructure. And to accomplish that, it uses the actor model. So the actor model, we don't have much time to get into all the details, but basically it's a way to model your system using these units of compute and state that are called actors. And these actors can only communicate with each other using messages. And then each actor instance handles at most one message at a time. And that means that there can only be one active thread inside of an actor. So that's also called a turn-based execution model. Um, so what it means is that if multiple messages comes in, one will be blocked, uh, is basically suspended in a queue. The other message is being handled, and only after that message has been completely handled, then the other message will get handled. And That whole mechanism makes dealing with concurrency really easy because you don't need to worry about multi-threaded code with synchronization mechanisms like locks and semaphores. All that stuff is typically pretty difficult to write if you've got an advanced complex scenario. So it's really great if you don't need to worry about it at all because there's only ever going to be one thread active inside of your actor. Now, Orleans uses a variation of the actor model called the virtual actor model. So in Orleans, actors are virtual. In fact, they aren't called actors at all. They are called cranes. And when I say virtual, it's like virtual, like in virtual memory. So you don't need to create cranes explicitly. You can just basically assume they are already there. So if you call a crane for the first time, it will simply magically spring into existence on one of the nodes in your cluster. And then that crane is available to start processing messages. Any crane will be available from any node, right? So you can kind of think of it as a distributed object. So let's dive directly into the code and just see how this works. Let's see how we can actually create a crane ourselves. So I'm going to switch over to my Visual Studio Code. And I've modeled all the entities in my pop crawler application as cranes. And one of the cranes I've got here is the crawler crane, which basically represents a single participant in a pop crawl, right? So what we'll see here is, first of all, we have this interface because each crane must have an interface. And the first thing we notice here is that this interface inherits from iCrane with integer compound key. So each crane must have an identity, so basically a key. And you can choose different types of keys. You can use a string or a GUID or an integer. And on top of that, you can also use compound keys, which are combinations. So you can have a combination of a GUID with a string or an integer and a string. And I'm using that last one here. Now, the reason why is that I want to support multiple pop crawl events in this platform. And this crawler crane should represent a crawler within the scope of a single event. So for my key, I've chosen a combination of the event ID, which is an integer value, and the crawler ID, which could be like an email address or a login name or something. Okay, so then we have the operations that we can invoke on this crane. So we have a couple of methods here to check in and out of a drinking venue. I also have methods to rate a beer and to get the current beer ratings. And I have this get status method, which basically just gives me the current state that is stored in the crane. So that includes the current drinking venue and all the ratings. And down here, if we scroll all the way to the bottom of this file, you can see that crane state. So this class represents the state that I'm going to store within this crane. And you can see I've got the current venue where I'm at, and I've got this dictionary I use to store my beer ratings. So scrolling a bit up again, let's go see, yeah. So here we implement the crawler crane. So I'm going to need to inherit from crane. And then, of course, it also needs to implement my interface. By the way, this interface, if you notice, these are all async methods that are returning task or task of a certain return type. That is required because, of course, when the cranes start calling each other in a cluster, it can involve network calls, and it's good to have asynchronicity there. All right, so in this crane, we want to store some state, right? So here I'm using the built-in persistence mechanism offered by Orleans. And to use that mechanism, you basically inject an instance of iPersistent state into your constructor. So here as the type parameter, I'm passing in my state class. And that gives me an object that I can use to read and write that state. Now here you can see I also have decorated it with a persistent state attribute. And that is used here to assign a name to this state object. And that's necessary because it's possible to use multiple state objects in a single crane, and then you need some way to distinguish between them. You can also use this to specify which underlying state store you want to use. So, for example, if I've configured like a SQL database, I could pass that in here so that Orleans knows which state store to use. I'm not doing that here. So that basically means I'm going to use whatever is the default. And for these demo scenarios, I'm using the in-memory persistence provider, which is very useful for development and test. It just stores the state in memory. And when you stop and restart your program, it's cleared again. But you have some out-of-the-box options like Azure Storage, Customized DB through the Table API. There's an ADO.NET provider for relational storage, and there's also a Amazon DynamoDB provider. So let's see what happens when we check in. So here we have the check-in method. So this method gets a reference passed in to the crane, to the drinking venue crane that we want to check into. Now, this is just a reference. So it is not the actual venue crane. So it's basically just a proxy object that contains the logical name of the crane that we want to reference, right? Because the actual instance could be on an entirely different server, or it may not exist yet because we have never called it before. So this is simply a logical reference. And the cool thing about that is that you can basically do everything you want with it. You can just pass it around between classes and cranes. You can store it in state. And if you come back in a couple of months, you can retrieve it from state, and it's still a valid reference to call that specific crane. So that's really nice. So if we look at the logic here, I first check what my current venue is, because if I'm already checked into this particular venue, then of course we don't need to check in again. We are done. If I'm not, I'm going to check if I'm checked in somewhere else. If I am, then we are going to tell that other venue that we are not there anymore. So I'm going to call the remove crawler async method on that one. And then finally, we add ourselves to the new venue, and I also store that in state, and then I write the state back to the persistence store. So note that I'm adding myself to that venue so that inside the venue crane, we can keep a running total of how many crawlers are currently at the venue. And that's really useful because that's those counts I want to show on the event map in the app, right? Okay, so let's do a quick demo. So I'm going, let me see, I need to go to the subfolder. I'm going to run this backend, and then I'm going to, just to show you that this is actually a distributed applications, I'm going to instantiate two of these. Now I'm still running on a single machine, right? So I don't want to have any port collisions. So I can pass in instance ID 1, and that will increment, whoops, I think I needed to do dash dash. Yep. So that increments my port number by 1, so that both of these applications are listening on different port numbers. But basically what I've done now is created a local cluster with 2 nodes. And it's still my machine, but it's basically the same scenario as if I would have 2 entirely different servers, each running an instance of my application. Now, the first thing I need to do is I need to set up an event, right? Because I just started it up, I'm using in-memory storage, so there aren't any cranes yet. So I need an event. So I can do that by posting to my API that is exposed by my application, and it has an events endpoint which I can post to, and my event data consists of basically a lot of beers generated by ChatGPT, and then some venues that I typically visit when the Bokkentocht is held here. So when I send this request, I get back a 200. Okay, so now we have that event set up, and now I can check into one of those venues. But first, let's see what our current status is. So I'm going to call this endpoint, which fails, and I'm not sure why. So let me check what's to execute. It looks like a plugin failure, actually. Yep, I think it was. Not sure why that happened. But if we get the status for my current login name, which is a Molenkamp, I get back that I haven't checked in anywhere, so venue ID is empty, and I didn't rate any beers yet, which makes sense, right? Um, and I'm sending this request to basically server number one, which the process which is running on 501. So let's now go ahead and check into one of the venues, but let's do that on server number two, right, which is running on 502. So that gives me back a 200. Okay, so now I'm checked in. And then let's go back to server one again and request that status again. And now we can see, hey, we're checked in at venue ID Herberg Jan. So think about this, because this is really pretty cool. Because we just used that crawler crane from two separate processes, right? Which again could run on two completely different servers without having to think about where that object lives or how we're going to access it. Right? All of that hard stuff is taken care of by Orleans. So if I'm calling a crane which is not running on the server where the request comes in, Orleans will simply take that request, serialize it, send it to the server where the crane is running, execute it, and again, the return value is serialized, deserialized, going back to the client. So that's really pretty cool. So you know what? While we're here anyway, let me show you the actual app. So the application I've written using Blade Server. Let's start that as well. And that's going to run, let me see, on 5501. So let's go to a browser, localhost. What was it? 5501, right? Yeah. Okay. So here we can see the Popcore app, and you can see already we are still checked in at Herberg 1. Herberg Jan, because there's a 1 there. And if you scroll down a bit, we have the top beers, but of course it's still empty because nobody rated something yet. But if I click on Herberg Jan, that will take me to this detail page. We can rate some beers. Let's say actually, I especially like this one from Brouwerij I. And let's check out again. So now this is 0. And if we scroll down, we have those top beers, Brouwerij I and Brouwerij van Onsbroek. Yeah. All right, so let's see how this let's see how this leaderboard is created. So let me go back to the slides for a bit. So what basically happens from the Popcore app, I can rate beer. I call the rate beer endpoint. So that's basically what happens when I click that thumbs up icon. So that goes into my API. My API executes the rate beer method on my crawler crane, which is the one we saw earlier in VS Code. And then the crawler crane will add that rating to the beer score crane. So that crane represents the total score of a single type of beer. So for each beer, there is a single beer score crane. And then that beer score crane will report that total score to the beer leaderboard. So there's a single leaderboard crane per event, and it will keep just a sorted list of all the beer score totals. And then the app can access that leaderboard, can request that list to render it in the app. Now, theoretically, if you have a really large number of crawlers, that may result in a high number of beer ratings that will eventually end up at the beer leaderboard, right? And that may put a lot of stress on that particular crane instance. So, to reduce that traffic, instead of immediately updating it, we can periodically update the leaderboard instead of in real time. So, let me show you how that works. I'm going to switch back to VS Code. Going to find my beer score crane. Here it is. So this is my beer score crane, and you can see it has a single method simply for reporting an updated rating. And then we have this unactivate async method. So this is one of the lifecycle methods that you can hook into. So whenever a virtual crane is activated because a call comes in, this method will fire. There's also a corresponding undeactivate, and that is just before a crane is deactivated, because not all cranes stay activated all of the time, because that would be a problem. Your memory would just be used up. So cranes that haven't received any messages in a while will get deactivated, and they will reactivate automatically again once a new message comes in. So anytime this crane is activated, what we'll do is we'll start a timer. And I've set this up to fire every 3 seconds. So when this fire timers, when this timer fires, we will report the score. So if I jump into this, what I'll do here, I first check if I'm still working on a task. So if the previous task is taking longer than 3 seconds, I'm not going to do any more work. I'm going to just let that complete. But let's say it's the previous task was completed. Then I'm going to report the score to the total crane. So I'm going to take all the ratings that I've got. I'm going to calculate a score based on that. So I'm going to turn those thumbs up and thumbs down into a 1 to 5 score. If that score is different than the last score that I reported, then it's useful to report it now. And I'm going to call that leaderboard crane. And to get a reference to that leaderboard crane, I can use the crane factory. I'm going to pass in the event ID because that's the key for the leaderboard. And then I can update the score. I save it in the last report score, and I'm done. So that's how that works with the leaderboard. Let's go back to the slides and look at the event map. So this is pretty similar to how the leaderboard works, but it has some additional stuff in it. So when we want to check in, I again make a call to that API. I call the check-in method on a crawler crane. Then the crawler crane will add a crawler to the drinking venue. And then we have that same kind of mechanism where the drinking venue periodically passes or reports the total to the event map. And then the event map basically has all of the totals, and it is used to render the map in the app. But in this scenario, I actually want to push those counts to the app, right? So if you have the app open and people are checking in and out, I want you to be able to see those numbers change in real time. So to do that, I'm going to use SignalR, which is a library that uses WebSockets to send notifications from a server to client-side web applications. And to use SignalR, you need to create a SignalR hub class. So you basically create a class, you inherit from the hub class, and now this hub represents basically the pipeline that can be used to send messages between the server and the client. And then in your program CS, you will need to add some code to expose that hub on an endpoint so that the web clients actually have something to connect to, right? So now we have a SignalR hub running on each of the server that the clients can connect to. So that's nice. But how can the event map crane now interact with those hubs? Because it needs to be able to call those hubs to push those messages down that pipeline, right? How does it even know which hubs are there? Because it possibly also needs to cross a server boundary. Now, fortunately, Orleans has this very nice feature called observers. And observers are a mechanism to receive events in ordinary .NET code from an Orleans crane. So it's a way to integrate your crane code with your non-crane code, right? And all you have to do to make that work is create an interface that inherits from iCrane Observer. Now, this is a one-way best efforts kind of scenario. So all the methods here must return either void or task. Um, but if you look at the implementation of my event map observer, then it's pretty simple. I can inject a signal or a hub context into my constructor. And then whenever that send venue attendance update at async method is called from my event map crane, I can simply take that information and give it to the context to send the message to all of the connected clients. So that will work. But now, of course, the next question is who creates these observers? And again, how does the event map crane get a reference to each of those observers? Because it needs, obviously, it needs a reference to be able to call into them. So to answer the first question, I've got these very basic .NET background services set up in each host. And they have the responsibility to create the observer. And to do that, they again use that crane factory class that we saw earlier. Only now, instead of getting a crane reference, I'm calling create object reference. And that gives me a reference to an object that implements that iCrane observer interface. And that reference I can pass around all throughout my cluster. So the observer services take that reference and they give it to a observer list. So observer list is a very simple crane. Its main responsibility is to just keep track of that cached list of observer services. And then it's very easy for the event map crane to just periodically call that observer list crane to get the list of observers. And then when the event map detects some changes, it can use that list of observers to call the on-venue attendance updated method on them. And that will flow through the observer, through the signal R hub to the client. So it's a bit of work. And if you're familiar with Signal R, you might be thinking, hey, just use a Signal R backplane like the Azure Signal R service, because that can solve the same problem without actors. But I thought it was a nice scenario of to show you how you can integrate basically your crane code with ordinary .NET code. So let's see this in action. Let me switch back to VS Code. And let me open up another terminal because I also have a simulator here. And that simulator is also built using Orleans. So what this does is it basically has only two cranes. It has an event simulation crane and a crawler simulation crane. So when I give it this command, it will start up a bunch of crawler simulation cranes, which and each independent simulation crane is going to act as if it is a crawler, right? So it's going to check in into one of the venues, rate some beers, check out, and select a new venue. So if I run this, and then let me see if this is actually going to run. Yep. And then switch back to my browser, you can see that people are starting to join the event and they are checking into venues. So this will, I think I selected 1,000 crawlers, right? So this will go to like 200 and then it will all balance out. And if you look at the top here, so these haven't refreshed yet because I didn't use Signal R here, but I did add in a very user-unfriendly way to refresh. If you click on top beers, you get a new list. So you can see there also rated a lot of beers. My rating algorithm is not that random because they're all at 4 stars. Let me see if we can improve that. No, guess not. But you get the idea, right? So
Yeah.
this works pretty well. And that is basically what I wanted to show you. So it's a pretty quick overview. Um, but I think it shows just how powerful Orleans is and how easy it is to get started with. One of the nice things about Orleans is that they really try to abstract away a lot of the complexity.
Hmm.
And they also spend a lot of attention to how easy it is to get to work with if you're already a .NET developer, right? Because we are using all the constructs here that we already use, like async await. We don't need to learn any new techniques about how to send messages to actors. That's all behind a simple awaitable call. The same is true for error handling. We don't need to do anything special. If a crane throws an exception, you can just catch that exception and handle it as you're used to, even if the crane that throws the exception is on an entirely different server.
Yeah.
So yeah, if you're already a .NET developer and you are even slightly interested in building distributed systems, I would say go ahead and try out some of the tutorials and the samples that are on the in the documentation, because
Yeah.
it's
Yeah.
really
We will
fun stuff to
probably,
toy around with.
yeah. And we'll probably get some links and we'll put them in the description for the show.
Yeah, we'll
So you can
do.
find it there. So, yeah. Thanks for showing us this. Like I said, I'm already familiar with the actor model in Akka.net, and
Hmm.
there are some differences, like you pointed out. But I think, as we saw in the code, it is actually pretty easy to start if you're a .NET developer, and also the way to combine your regular ASP.NET Core or other frameworks that you're already using with Orleans. I think that's really, yeah, that's really powerful. So yeah,
Yeah,
cool.
definitely.
Um, yeah, and also like I saw in the demo, I think that's a little warning to people starting working with the actor model, because it is a different way of thinking about things, right? So you really have to model your problem in a certain way, because else
Yes.
you would probably have some bottleneck in your design somewhere.
Yeah.
So really start with a design with some drawing, and then actually start building it before you
That
actually do that.
that
So
that,
yeah,
that that's a great tip, because well, this works best, right, in scenarios where you do have, or you can at least break down your problem into a lot of smaller entities.
exactly.
um,
Yeah.
and it's best if those entities have a lot of concurrency, because
Hmm.
that's where the actor model is really going to help you.
Yeah.
But yeah, it's definitely true what you said, because this design that I now have with the type of cranes that I now have is my fifth or sixth iteration.
Yeah.
So it takes some time to get up with the correct design, but it's good that thinking about the functional stuff is the hard part, right?
Yeah.
Because that's the stuff that we want our applications to do, and then if we know what we wanted to do, then the implementation should be easy.
Yeah, yeah, and I didn't see any stuff around, message brokers or stuff like that, or how to communicate between these actors. So a lot of that heavy lifting is being done by the framework and the runtime that is running that. So that's
Yep.
actually where the power is. Yeah,
Yep.
cool. So thanks for showing us.
You're
I hope
welcome.
you watching also liked it and start working with Orleans. Like I said, we will put some link in the show notes to get you up and running. If you like us, please subscribe to the channel, and then we will see you at the next episode. Thank you so much. Bye bye.
Bye bye.